Hey everybody, today we're going to start new section, all right, but still we're going to be dealing with integrals, all right. So on the quiz you guys took yesterday or Wednesday, depending on Wednesday when you guys took it, we did approximating a curve, the area of a curve, and we did the exact area, but that was only if it was some sort of geometric shape that we knew, like a triangle, semicircle, trapezoid, something like that. All right. Now, remember, integrals stand for area under the curve. All right. This thing right here is supposed to be an integral sign. Just got screwed up on the PDF, but whatever. So we know it stands for the area under the curve. All right. Like I said, we did approximate area. We did the exact area. Today we're going to another way to find the exact area besides just using geometry. And it's called the first fundamental theorem of calculus. All right. And here is the definition, but like normally, don't stress yourself out too much with that. All right. So we're going to take a look at these examples, and then there's not going to be any other assignment today except for doing this, looking at these notes, and then you guys will have a worksheet the next time we have class to practice. All right. So here we have an integral that's x cubed dx, and it going from 1 to 3. Notice the smaller numbers on the bottom to 3. So we are going to find the exact area of this. All right. And what we're going to do, first thing is we're just going to integrate this. So we use the power rule, and this is going to be x to the 4th over 4. Now, we're not going to put the plus c. All right. We're not going to put the plus c because we're looking only from between 1 and 3. So we don't have to worry about that constant. And what we're going to do is now we're going to put this little line here. This is the way I write it. And what we're going to do is we have to plug in 3, and we're going to plug in 1 into x, and then we're going to subtract those two values. All right. So you see where here it says here f of b minus f of a. So we're going to plug in 3, whatever's on top, in for x. So it's going to be 3 to the 4th over 4. All right. Minus, all right, now we're going to take the 1, this number here, and plug it in. So it's 1 to the 4th over 4. All right, 3 to the 4th, 3 squared is 9. 9 times 9 is 81. So that's 81 over 4 minus 1/4. And 81 over 4 minus 1 over 4 is 80 over 4. And 80 over 4 is just 20. So our answer for number 1 is 20. All right. So that is the exact area. If we were to graph x cubed and we would take the area under it from 1 to 3, the area would be 20. All right. So to repeat the steps, we integrated first. That's why we got x to the 4th over 4. All right. We then took the top number 3, plugged it in. We took the bottom number 1, and we subtracted them. All right. Let's go ahead and try number 2. All right, so we're taking the integral of x squared minus 3 from 1 to 2. So we're going to go and integrate x squared, which is x cubed over 3 minus, now we do 3, which is 3x. All right, so we just integrate like we did way back when we started this chapter. All right, now what we're going to do is we're going to plug in 2 and we're going to plug in 1. All right, so I'm going to take 2 and plug it in there. So 2 cubed, just to save time from writing, 2 cubed is 8. So we get 8 over 3 minus, now the 2 also has to go there. So 3 times 2 is 6. All right. Now, minus, now we got to plug in 1. Got to plug in 1 there, and we got to plug in 1 there. Now notice what I'm doing here. I'm putting this all in parentheses because we're subtracting the whole thing of this. So if you don't put the parentheses, you're probably going to forget to distribute the negative. So I put in a 1, and I get 1 cubed, which is 1, so it's 1/3, minus 3 times 1, which is 3. All right, so now if I distribute the negative, right, this is a negative, and this is now a positive. So I get 8/3 minus 1/3, which is 7/3. and they get negative 6. This turns to a plus 3, which is minus 3. 7 over 3 minus 3 over 3. Well, 3 is 9 over 3, so 7 minus 9, negative 2. So it's negative 2/3 is my answer. All right. So you're just integrating and then plugging the top number in, plugging the bottom number in, and subtracting those two answers. All right. All right, on to number 3. All right, so let's go and first integrate 3 root x. All right, remember, how do I write the square root of x? This is really the integral of 3x to the 1/2. All right, so it's 3x, add 1 to 1/2, which is 3/2. Now, normally you just put the exponent on the bottom, but we have a fraction, so we have to multiply by the reciprocal. So the 2 stays on top, the 2 goes on the top, the 3 goes on the bottom. These 3's cancel. So what we end up getting is 2x to the 3/2 right there. 2x to the 3/2. All right. The reason you don't put 3/2 because that'd be a complex fraction. You flip the reciprocal, take the reciprocal of the exponent. So the 2, which on the bottom, goes on top. The 3, which is on top, goes on the bottom. Those 3's canceled. Or you could do 2 times 3 is 6. 6 over 3 is 2. Same thing. All right. And now we're going to plug in 4, and we're going to plug in 4, and we're going to plug in 1. All right. So take 4, and we're going to plug it in. Now, what is, so we got 2 times 4 to the 3/2. All right. Now, what does 4 to the 3/2 mean? 4 to the 3/2 means the square root of 4 cubed. So the square root of 4 is 2. And what is 2 cubed? 8. So this means 2 times 8. All right. Minus, now let's plug in our 1. So it's 2 times 1 to the 3/2. Well, 1 to anything is 1, but the reason is because the square root of 1 is 1 and 1 cubed is 1. So that's minus 2. So 2 times 8 is 16. 16 minus 2, and our answer is 14. All right. Now, the tricky part with this one was probably right here, 4 to the 3/2. So just to go over that again, 4 to the 3/2. The bottom number is the root. This is the power. So you take the square root of 4, which is 2, and then cube that, which is the same thing as the square root of 4 cubed. 4 cubed is 64. The square root of 64 is 8. You can do it either way. It doesn't make a difference. All right. So that answer is 14. All right. Now we have one with trig. Hard to tell, but this is secant squared of x dx that we're going to take the integral of. All right. So remember, so when you're taking the integral, you have to think the derivative of what trig function is secant squared x. So if I were to write all the trig functions out, when I look on the right side, I would see secant squared x. On the left, what would be there? All right, and hopefully everyone's yelling at home, oh, that's tangent. All right, so it's tangent x, and then we're going to plug in pi over 4 and 0. All right, so I got to take pi over 4 and plug it in. So it is tan of pi over 4 minus tangent of 0, because we got to plug 0 in. Now, pi over 4, if you guys remember, pi over 4 on the unit circle is root 2 over 2, comma, root 2 over 2. Tangent is y over x. So root 2 over 2 divided by root 2 over 2. Whenever you divide the same thing, you just get 1. All right. 0 is right there. 0 is 1, comma, 0. If tangent is y over x, it's 0 over 1, which is 0, and 1 minus 0 is 1. So our answer for that one is 1. All right. Once again, the reason tangent pi over 4 is 1. On the unit circle, pi over 4, all pi over 4s are root 2 over 2, root 2 over 2. It's the same x and y coordinate. When you do tangent, it's y over x. So when you divide the same thing, it's like 5 over 5 is 1, 10 over 10 is 1, a million over a million is 1. Root 2 over 2 divided by root 2 over 2 is 1. That's where that 1 comes from. All right. All right. Now, last one on this front side of these types. All right. And it's a little bit different because we have an absolute value. All right. So when you have an absolute value, what's going to end up happening is this. You're going to have to split it into two integrals. All right. Two integrals. Think of it this way. Every time we solved an absolute equation back in like pre-algebra, you had to write two equations in order to solve it. So in order to do this, we're going to have to do two integrals, kind of like the negative part and the positive part. All right. So it's going to be an integral plus another integral. All right. Now, the bounds on the integral, whatever this is here, is going to be your first thing here. Whatever this is going to go there. Now, to figure out what goes on the top here and the bottom here, these are actually going to be the same thing. What you're going to do is we're going to set whatever is in the absolute value equal to 0. So we're going to do 2x minus 1 equals 0. So when we solve this, we get x equals 1/2. All right, this right here is our bound there and there. Okay, so we're going from 0 to 1/2 and then 1/2 to 2, which you put them together is the same thing as 0 to 2. All right, now if I were to plug in, let's say, let's do this one, 1/2 to 2. Let's say 1. That's a number that's between 1/2 and 2. If I plug it in there, I get 2 times 1 is 1. Sorry, 2 times 1 is 2. Minus 1 is 1. It's a positive number. If something is positive, that means it stays the same. So anything between 1/2 and 2 is going to make whatever's in the absolute value positive, which means we're going to write it as 2x minus 1. If I get a negative, I take the opposite of it. Anything between 0 and 1/2, let's say a fourth. 2 times a fourth is 1/2. 1/2 minus 1 is negative 1/2. Since that's a negative, we take the opposite of that, which is negative 2x plus 1. So if I had plugged in something and got a positive here, I would have kept it the same. If I get a negative, I switch it. Positive, the same. That's what happened here. Negative, you take the opposite of it. So now we're going to do what we've been doing in all the other problems. We just have to, it's just two integrals. That's it. All right. So we're going to integrate. So when I integrate negative 2x, I get negative 2x squared over 2 plus x, but 2's cross out. So it's just negative x squared plus x. And then we'll plug in our 1/2 and our 0. And we'll do that in a second. Then we get, integrate this, we get 2x squared over 2. The 2's cancel, minus x. And we're going to plug in 2 and 1/2. All right. Let's use this. All right. So now I plug in. I get 1/2 squared, which is 1/4, but there's a negative, so that becomes negative 1/4 plus 1/2. So that's by plugging this x in and that for there. Now I'm going to plug in 0 in both spots, right? Well, what's 0 squared? 0 plus 0 is 0, so minus 0. Just going to write, you don't have to write that there, but I'm just writing it to show that we actually did plug in 0. Plus, now I plug a 2 in. That's 2 squared is 4. Minus, plug this 2 in there, 2. Minus, put it in parentheses because it's minus this whole thing. 1/2 squared is 1/4. And then minus 1/2. Right? So now we just need to simplify this. All right. I'm going to put my work right there. All right. Actually, I don't use that color. Let's use a little green. All right. Negative 1/4 plus 1/2. That is positive 1/4. All right. So these are done with. 4 minus 2 is 2. Then I'm going to distribute this negative, and I get negative 1/4. And then I get plus 1/2. 1/4 and negative 1/4 cancel. 2 plus 1/2 is 2.5, or 2.5. There you go. All right, so when you have an absolute value, you split up into two integrals. This 0 here goes here, the top one goes there. You set this equal to 0, all right? 1/2, that goes there and there. And then it's almost like 1/2 is your critical value, right? Pick a number between 0 and then you got 2. And you're plugging a number in to see if it's positive or negative. So we got a negative here and a positive here. The positive one stayed the same. Where it was negative, got switched. And then you just integrate and plug in like we did on all the other problems. All right. All right. Last thing that we will do is something called the average value of a function. Okay. Don't worry about this drawing here. So if f can be integrated on an interval from a to b, then the average value, which also means the average height, of f on that interval is 1 over b minus a on the integral from a to b of f of x dx. All right, blah, 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 blah. Now, this is what you really need to know. This is what we just did, right? So we are going to do it exactly what we just did. The only difference is this. To find the average value, once you find your answer, you're going to multiply it by 1 over b minus a, where b is the top number, a is the bottom number. All right, a is where you start the interval, b is where you end. All right, so the area of region on the curve is equal to the area of the rectangle whose height is the average value. So you're taking the average height. That's all you're doing. Okay, now, so if we were to look at this example, all right, find the average value of f of x equals 3x squared minus 2x on the interval from 1 to 4. All right, what we are really doing is we are taking the integral from 1 to 4 of 3x squared minus 2x. All right? This is what we just did on the previous problems. All right, so you're going to integrate, plug in 4, plug in 1. Don't even worry about the average value until the end. So 3x squared, that's 3x cubed over 3 minus 2x squared over 2. 3's cancel, 2's cancel. So what you have is x cubed minus x squared. And we're going to plug in 4, and we're going to plug in 1. All right. So now I plug in 4. 4 cubed is 64. I plug in, minus, and then I got to plug it in here, 4 squared, which is 16. Minus, in parentheses, plug in 1, I get 1, minus 1, which is 0. All right, so this is 0. So 64 minus 16 is 48. Now, if this was just our problem, 48 would be our answer. However, we are trying to find the average value, which just means we're going to take this answer and multiply it by 1 over b minus a. Well, in this problem, b is 4, a is 1. So what is 4 minus 1? It's 3. So I'm going to do 48. So I get 48 times 1 over 3, which is 1/3. And 1/3 of 48 is 16. That is the average value of the problem. All right. So what I want you guys to do is just try this last example. Find the average value of f of x equals x cubed plus 4x on the interval of 0 to 2. And that is going to be your homework. You don't need to submit anything. Just give that problem a try. All right. What will happen is next time at class, we'll do a practice sheet with this and just then we'll go from there. All right. So nothing, you guys don't need to submit anything today. You just need to watch this video, take notes. If you can't print out the thing because you have a printer, you don't want to waste paper or ink, like I get it, don't worry about it. Just take the notes in your notebook. All right. Just make sure you refer back to them, and you could always go back and watch the video again if you forget something later on. All right. So hope you guys enjoy the rest of your day. All right. Stay safe, stay healthy, and I'll talk to you guys next time. Bye.